Hello everyone, and I'll just share my screen. The tech talk is specifically talking about the developments of the machinery safety standards, so specifically looking at ISO 13849 and IEC 62061. As Chris introduced me, I'm the local section chair of the Central Northwest section of the InstMC, not the whole institute. But I'm a principal consultant here at RPS and certified functional safety professional in process and machinery sectors. I've been working in the real world for 32 years. More than 32 years experience, and 10 years of that has been in consultancy. The bit I forgot to put on this slide is I sit on MC3 British Standards Committee for machinery safety on behalf of the Institute. Okay, so this is what we're going to do, a little bit of a background to machinery standards, and then looking at the differences in the two standards that we're talking about, and then the $101 question at the end: which standard should you use? Now, just as a preamble, we're not going to talk about CE marking, UKCA marking, apart from a very brief mention of it in the standard. Which standard should you use at the end? Please don't ask me about UKCA marking and where's that left after Rishi Sunak's announcement in August and the confirmation by Bayes towards the end of the year that the indefinite acceptance of CE marking for machines in the UK. Because I don't know the answers, HSC don't know the answers, and nobody knows the answers of what's going to happen at the moment. So just to briefly go through machinery standards. So there are three main types of standards. There are Type A standards. They're the basic safety standards, providing basic concepts, principles for design, and general aspects that can be applied to machinery. There's then Type B standards. They are generic safety standards, deal with a single aspect or one type of safeguard that can be used across a wide range of machinery, and they're split into B1 and B2. So the two standards we're going to talk about today, ISO 13849-1 and IEC 62061, are both Type B1 standards, as they focus on a particular safety aspect, and there's mention there of functional safety. There's also things like safety distances, etc. And then there's Type B2 standards that focus on specific safeguards, things like two-hand controls, light curtains, guards, and the pressure pads, etc. Then there are Type C standards, and they are specifically written for the machine. So they deal with the detailed safety requirements to the particular machine or group of machines. So things like robots, conveyors, power presses, etc. So that's the hierarchy that we have for standards in the machinery world. It won't surprise you to find there are many standards in this area. So this is how they look with regards to a sort of triangle of control. ISO 12100, which is the risk assessment standard for machinery, is in the Type A box, and literally that is the Type A standard, with a couple of variants in there. The Type B that I've just mentioned, 62061, which is obviously the IEC version for functional safety, and ISO 13849, which is the ISO version for functional safety. And then we have the B2s. So the two examples there, 13850 is emergency stops, and 13851 is industrial trucks, I think. I think that's what it is. My notes have vanished on the screen. And then Type C standards, there's EN ISO 10218, which is robot standards split into two parts, one for robot manufacturers and one for integration into a robot cell. EN 12053 and 12999 are two of the other ones that I say I've lost my notes, so therefore I can't tell you what those ones are. In the journal that's linked to the Machinery Safety Directive in Europe, there are around about 1,100 Type C standards, around about 400-ish Type B standards, and then say 4 entries for Type A, which are all variants of 12100. a brief mention with regards to relationships with EU directives, and I will mention the UK position as well. So there's a journal available, and they are in relation to the Machinery Directive 2006/42 EC, and the journal keeps a record of the standards which are harmonised to that directive. And what does that mean? Well, if you follow the standard, you can then gain a presumption of conformity for CE marking on that aspect of the machine. Currently in the UK, so now machines are supplied under the Supply of Machinery Safety Regulations 2008, and that has a list of designated standards. And at this very moment, early into UK CA marking, not complying with EU directives, their lists are very similar. Those lists hopefully will stay similar going into the future. But one question that really comes up to when we're talking about standards and marking of machines, etc., is, do we really need to do it now we're not in Europe? Well, in the UK, the provision and use of work equipment regulations actually does ask in Regulation 10 for machines to be marked to the right marking for the community. Obviously, previously that meant having a CE marked machine because we were part of Europe, and now that means CE or UKCA marks for machines used in the United Kingdom. You know, Northern Ireland, so yeah, United Kingdom, Northern Ireland is CE/UKNA mark. So just because we're doing pure doesn't mean we don't have to do the marking anymore, because we do. Okay, right, so 62061, let's look at that one first. So it was revised in 2021 and is a harmonised standard to the EU Machinery Directive. That harmonisation and the presumption of conformity came in on the 13th of April 2022, even though the standard was released in 2021. And it's a machinery sector standard based on IEC 61508. This is now what it's called, so safety machinery, functional safety of safety-related control systems, and it's not technology specific. So what does that mean? Technology, a light curtain or whatever. Well, what it means is you can use this standard now for electrical, electronic, hydraulic and pneumatic protection system safety functions. In the previous revision, the 2005 revision, it was only electrical, electronic components and functions. So if you were trying to implement a pneumatic or hydraulic system, then this standard wouldn't be for you. But in this revision now, in 2021, it covers the other technologies as well. However, it's not intended to form a standard for designing complex programmable electronic systems or elements. They should be designed in line with 61508. This standard is a sector standard, which is the implementation and use of components that have already been designed to the other standard. And I did put a note there at the bottom of the slide about low demand. 62061 is entirely high demand or continuous functions. There was in one of the updates of the standard a section on low demand, and it was removed when there were issues with how it was being used. Low demand was being used in relation with the update. So if you got low demand functions, this isn't the standard for you. And that's worth saying, really. Same for 13849. Machinery is accepted as mainly being high demand functions or continuous operation functions, and therefore neither of them lend themselves to low demand. Although a SIL is a SIL and a SIF is a SIF, and performance levels and performance levels, and you might be able to justify that your high demand systems also applicable to something that's more low demand, but it's not aimed or intended to be that way. Okay, so just as a bit of a summary of where would you use what standard if you're in the world of the machinery sector. So if you are a manufacturer and a supplier of devices and wishing to follow the IEC route rather than the ISO route, then if you're manufacturing widgets, components, etc., you should follow the requirements of 61508. Once someone's made manufactured those components, then if you are designing the system, integrating the system, or the end user, then 62061 is the relevant standard for you. Now, if you know the 2005 version of the standard, then the first definition shown on this screen has actually changed between the versions. So safety-related control system, as it's now called, used to be called a safety-related electrical control system because the standard was purely related to electrical systems. And now it's got hydraulics and pneumatics in, they've just dropped the electrical in the definition. But this is just a bit of a translation between 61508 terms and 62061 terms. Our safety function remains a safety function. Our equipment under control is our machinery, and our equipment under control system is our machine control system. So just a bit of a translation if you are used to one of the standards and not the other one in there. So just having a quick look at the timeline for this standard, where does it come out? So IEC 61508, which is the standard that it's based upon, that all 7 parts of the first edition were released by the year 2000. 62061 was then written on the basis of 61508 for the machinery sector, and that was released at the first edition in 2005. 2010, the second edition of 61508 comes along, and then there was an attempt to try and create one standard between ISO and IEC, which wasn't successful, and therefore both standards had a interim edition in 2015. 62061 left it as the first edition with an amendment, and ISO did actually release another edition. And then since 2015, the committee have been updating 62061 to a second edition. So in 2021, that was released and approved and voted on, etc., from all the international standards committees. Sorry, all the country standard committees through IEC. Yeah. Okay. So some changes to note. So just I'm not trying not to just display the whole standard in front of you, but just see key points of things to think about when using the standard between the two editions. It's probably not everything, but it's just some key things. So the design process has been tweaked a little bit. We're going to go through that in the next slide. There's the mention of the non-electrical technologies, so the pneumatics and hydraulics. There's been an update to the software requirements side of things. So recognising as 61508 has and the other sector standards around full variability language, limited variability language, etc. And there's now some security requirements within 62061. It's a very brief mention of security. It's not intended to replace IEC 62443 series or ISO 2701, for example. But there's mention in there that we ought to consider security when designing our machines, etc. Machines and those safety functions. So let's have a quick look at the design process steps that now exist within the standard. So we need to identify our safety functions. So that's traditionally and still remains the same of doing our risk assessment, our machinery risk assessment, i.e. to ISO 12100, using HRN numbers or whichever method you choose to use to identify what safety functions are required. Then we need to work out which of those are safety critical, and then determine the safety integrity level for each of those safety functions. The matrix method is still there. The way of doing it is exactly the same. The only thing slightly different is that it now gives us answers in SIL or in performance level should you wish to use it, which was a bit of a sort of translation in the old days. It's now actually in the standard. We should determine what the equipment is needed for the safety function and then split it into subsystems. So it's sort of bringing in the subsystems basis within 62061 consistently with 61508. We then select what equipment we'd like to use for the subsystems and then look at whether that proposed design and will will meet the SIL requirements that we have. So there's section the sixth section of the standard design process. It gives us some additional requirements for things like diagnostics, architecture, the reliability, and the addition in this version of systematic safety integrity, including software in there. Then the implementation, and then verification and validation. So I'm more aligning to the safety life cycle that we've seen in 61508. Here's that SIL determination table. This is taken straight out of the 2021 edition of the standard. Previously, we only had the dark lines that told us the SIL values, OM being ordinary measures, I think it is. So it's basically less than SIL 1, and as the process sector would call it, a low integrity safety function. And now it lines up, it shows you where we are with regards to performance levels if we were using performance levels as our measure for how much we need to deploy safety functions. Noting that we go from SIL 1 to SIL 3, there's no SIL 4 within this standard. It stops at SIL 3, but the performance levels are A through to performance level E. So just, there we go, OM, other measures, basic safety principles. So there is some guidance in the standard of how you can implement an OM system within machinery area. And just as another thing they've added into the standard, it's put this table in place for the probability of dangerous failures per hour. The D off the end has gone, because it used to be PFHD. Within the standard, and it gives us that 10 to minus 5 per hour PFH is a SIL 1 in 62061, at least a SIL 1 in 61508, and then performance level B or C in 13849, and then this other standard, which I'm not quite sure what it is, 61496, type 2 in there. So you can see now from this table what your actual numerical target will be as well for doing our SIL determination and working that into later design. The standard gives us an idea of what the subsystems look like, because that's then going to feed into working out our design parameters, our architectural assessment, for example, our that's done by subsystem. Similarly for systematic capability would be done by subsystem, with the actual reliability on the PFH achieved is for the whole function. So it just shows us in here a physical view of how you ought to look at your safety function. It gives us some architecture designs in 62061. So we have our basic architecture for subsystem elements in architecture A. Architecture B, we are bringing in redundant elements. So 1 out of 2 votes, and in the example we see there with common cause failure. So looking at what common causes could cause each of those elements to fail at the same time. C brings in diagnostic functions, so things like discrepancy checking between 2 independent values. That also that gives us extra confidence that the devices are working correctly. And then D is a mix of both, so that's obviously the highest integrity in there with diagnostics between our voted arrangement and common cause failure parameters. It then gives us what the mandated requirements are for our different levels. So if we've got hardware fault tolerance of 1, like of D and B, then it gives us what the concepts of basic safety principles, well-tried safety principles, and then consideration of common cause factors. It is referring out to 138.492 2012. That has not yet been updated, and at some point we'll go and be merged completely with 13849 Part 1. But at the moment, it's giving you references to go and look there to work out what these components look like and these principles. And then it gives us our hardware fault tolerance table that once we know the safe failing fraction of the device and the hardware fault tolerance, it will then give you the the achieved architecture based on what you're designing. Table's almost identical to the one in 61508, with a few notes in there for things like SIL4 not being considered within the standard. So go off and look at 61508 Part 1. Right, so this is one change on software concepts. The V model's gone in 62061. They've now brought in different levels of application software. They're trying to move away from just software, but talk about application software. So level 1 is application software using limited variability language, LVL, things like ladder logic, function blocks, etc. That can be used up to SIL3. I think. Sorry, my notes are gone. Level 2 is using another language other than LVL, and it gives it. So either this one SIL3 and that one SIL2, or the other way around. And then the application software using full variability language, and it basically says we go back off to IEC 658 Part 3 in order to use full variability language. This is things like C++, Visual Basic, etc., etc. This standard isn't giving you enough guidance on the use of those types of softwares. So it's giving you now some specific guidance on the different software types. Oh, here we go. I did put bubbles in. So 62061 up to SIL3 following this standard, up to SIL2 if you're using application software other than LVL, and then 61508 for Part 3 for full variability language. So there's guidance in the standard when you can use it, what you can use it, and obviously the assumption there is that the modules in use in the application program that you're using are suited for safety program application rather than just a normal control software basis. So approved in software libraries. So just moving on to 62061. This was revised in 2023 and therefore it's not yet harmonized. So we saw with 62061, it was released in 2021 and it was harmonized in 2022. It's just a little bit early for that harmonization to have been fully completed. There's no expectation that it won't get harmonized. It's just timings wise with the processes that they have to go through. It's now titled very similarly to the previous version, Safety of Machinery, Safety Related Parts and Control Systems, Part 1, General Principles for Design. As I mentioned earlier on, Part 2 has not yet been revised. That's still on the 2012 version. And the second edition in 2006 replaced the N954. So those of you that still have a copy of 954 knocking around, this is the current version of 954. As 62061, it's not technology specific and can be used for any energy source, and that has been the case for this standard for a long time. And now can be used also for programmable systems. So the electronic and programmable electronic aspects of the standard now roughly in line with 62061. They're not exactly the same, they're not identical, but the simple electrical and electronics, which was the intent for 13849 in the past, has moved on to programmable systems as well. So this is the timeline for main points on the timeline for 13849. So in 1996, it replaced the N954 with the first edition. 2006, the second edition came around just a little bit after the first edition of 62061. So this one's been around longer than 62061. There was a corrigendum in 2009, similar to the 2010 updates in 62061. 2015, there's that third edition in line with the amendment for 2009 is roughly around 615.08 update. 2015 is where the amendment to 62061 came, and then obviously 2023 there's the fourth edition of 13849. So this point here is, this is where I think the project to merge the two standards was sort of abandoned, and then each of the groups issued updates. ISO used an edition update, a third edition. IEC used an amendment in 62061. So there's a new structure within 13849. Things have moved around a little bit. Some of it's new, and other parts are not. They're enhanced. So as per most standards now, we have the scope, the normative references and terms and definitions, and then an overview of what the standard's trying to do, the first four sections. Then we got the specification of safety functions. The risk graph is still here in 13849. Then we're into design considerations, things like reliability, architecture, systematics, very similar to 62061. Software safety requirements, the V model's been changed in here. And there's two different types of softwares that we'll talk about later. And then the verification that achieved performance level meets the required performance level, similar to the 62061. So it's reliability with probability of MTTFD. There's diagnostic coverage, there's common cause failure, there's systematic failure in there, as well as architecture. So that's new in there. Ergonomic aspects of design is new, a smallish statement in there as a new concept. And then validation's been brought from 13849 clause 2 part 2 clauses 4 to 11 into part 1. And then maintainability is enhanced from previous version, same with technical documentation, the same with information for use. So they've got new section numbers based on the new structure, but the enhanced provision of what was there before. So again, I'm going to just point out a few parts on here. Another difference is now there's a concept of a safety requirement specification. So that's been around in 61508 since the first edition and other sector standards in the IEC range. It now gives us A through to M of things that we should consider and document for our machinery safety functions following 13849. The safety requirements back then we can use to then build our safety functions too. In this following this standard. So if we just see here on this one, we've got brief descriptions and titles of the function, what events trigger the function, i.e. the demands and the causes, the reaction to be initiated, so what do we want it to do, and how are the outputs going to reach the intended safe state, the required performance level, the response time, so how quickly do we need it to respond, and then operating modes during which the safety functions to be active. So in the machinery world, obviously there's more. There's teaching, normal auto operation, manual operation, setup, etc., etc. And as I say, goes on to item M. I've not copied all of them into this presentation, but this is the clause 5213. If you want to go and take a look at it later on. These are the factors that we now need to work out and document to say we've achieved our performance level. So architecture, so the subsystem category assignments, so the categories and the design still exist in 13849 part 1, and then it helps us align to each of the performance levels. we've got to evaluate applicable qualitative requirements are being met, like basic safety principles, well-tried principles, well-tried components that we saw in the 62061 architecture review, and evaluating the required behaviour under fault conditions, making sure they're met from what we write as our requirements. We obviously need to understand our MTTFD for the single components, and then what that equates to over the full safety function. Diagnostic coverages, common cause factors, software design effects, and there's our other systematic failures. So obviously there's other things in how we design and implement and manufacture and implement devices for a systematic perspective that are now defined in there. Here's our architecture categories. For those who have seen the previous version, they look identical. I think they haven't been tweaked at all. Category B and 1 are still a single, a single line with no redundancy. We're then introducing category 2 some monitoring, more devices and components in 3, and 4 with feedbacks in between. So they're exactly the same as they were before. It's also implementing the combination of subsystems, similar concept to what we saw in 62061, an input subsystem, logic subsystem, output subsystem. Again, we would be looking at architecture and systematics per subsystem, and then our reliability and PFH across the whole safety function. The diagram is still there for us. So working out what our diagnostic coverage is, our PFH, and then the other bits, the blocks. Apologies. Can't remember what the black blocks are and the other blocks without looking. But it gives us that once we've got our PFH number, our diagnostic coverage, and the other one, which I can't remember, then it'll tell us which performance level we're achieving in there. Once we take a break, I'll be able to go back and just remind myself what the different shadings are. Software-wise, they've split software in the standard up into 2. Safety-related embedded software. Here's our full variability language again. And it gives us measures for components with a performance level requirement A through to D. And it gives us the clause reference there. And then if it's performance level E requirement, then we must go back to IEC 658 part 3. So in 62061, if we're in full variability language, we were going straight back to 61508 part 3. In 13849, we do have some aspects that we can do with embedded software. And then the safety related application software, typically in limited variability language, but it might be things like fixed program language or other lower languages. Then there are measures detailed in this standard for performance levels A through to E. So it gives you that extra room for the higher performance level requirements. Obviously, this is assuming that the software that has been written as the embedded software is just being used and already been pre-assessed at that level in here. So here's our simplified V model. So this is for our full variability language for our embedded software. We have our safety related requirements specification, and then we go through design, module design, coding, testing, integrity testing, and validation, and we go back round the circle to check that we've met our requirements in full, and then we end up with a validated software. Now, if we're using the application route, then it is basically we have our safety requirement spec. We then code it in line with how the module that's been pre-validated works, and then we validate back that we've met what we wanted to do. But we don't have to build the modules anymore. So this is the limited variability angle of things, where the predetermined route has already been validated through the full variability language route. So this split out slightly, and it has changed slightly there. So high level key messages. So sorry, I've no idea why I went on mute. My apologies. The standard which is more appropriate depends on what you're trying to do. So I don't know if you caught that last bit, because I don't know if it's muted or not. This is the biggest question I always get asked by customers: is which one should we use? Now, it all depends what you're trying to do. Currently, if you're looking at machinery marking for CE, UKCA or NI, then at the moment the 13849/2023 one isn't yet harmonised. So if you're trying to use that standard, then the one that is harmonised still is 2015. So just bear that one in mind. If you've got a specific standard for the application, i.e. the Type C standards, things like robots, conveyors, etc., then you could use that one. Or you should use the one that's most appropriate, that you don't have to bend requirements to make it fit. So a lot of people use 13849 Part 1 for machinery protection. 62061 is just as valid, but please note these are both just for protecting machinery-based hazards. Use of the machine might need evaluation to other standards such as IEC 61511. So if we take a compressor, for example, the manufacturer might suggest that there are protections for the machine. So things like speed control, overspeed protection, that if the machine goes too fast, the compressor can fall to bits and bits fly everywhere and cause harm to people. Well, you might also have to evaluate the use of that compressor for blocked outlet or high suction pressure from a process perspective that could cause hazards. As we mentioned before, neither of these standards are low demand standards. So therefore, the low demand scenario of something blocking the suction, increasing the pressure at the suction or blocking the discharge, are probably more appropriate to go down 61511 route for that side of things, and a 13849 or 62061 route for the machine just not working itself properly and causing harm to people that way. So there's nothing wrong with having two lots of assessments, as long as you then meet those requirements when you then validating the use of the machine. It may be that there's a lot of the time that it's only machinery issues like a robot cell or a use of a conveyor, for example. And what will the regulator expect you to use? Well, they will have their view, but both standards are recognised against the machinery directive, noting the pending harmonisation of 2023. And again, don't forget those Type C standards taking precedent over Type B standards, but be careful because Type Cs take a long time to update. You still, as an operator of a machine, still need to demonstrate your ALARP. So it might be that some of the requirements in Type Cs may need to be updated with, for example, an updated sill level or performance level for the interlocks. But if you are in doubt and you've got a good relationship with your regulator, just ask what their viewpoint is. They may have a preference. HSE representatives do sit on the BSI committees and international standards committees, so they are working with the standards all the time. So if your inspector doesn't know, then there'll be someone in HSE that will be able to give them a guide as to where you should go to if you get my drift. Chris, I think I'm a little bit short on time, but that hopefully that's been useful. I don't know if we've got any questions, Chris, because I've not seen the comments, but I will try my best to answer any questions if anybody's got any.